In our previous video, we took a look at using reduction formula for integrals of the form x raised power n exponential x dx. And now we'll be using reduction formula for integrals of the form x raised power n cos x dx. Now, let in be equals to the integral of x raised power n cos x dx, and then we will have the reduction formula to be given as in is equals to x raised power n sine x plus x nx raised power n minus 1 cos x minus n into n minus 1 in minus 2. Now let's take this example. We're given the question to integrate x squared cos x dx. Of course, we can use integration by parts to solve this. However, we'll just be integrating 2 times. But using reduction formula, we can say that let I2, because comparing this to this, we have that n is equals to 2. So we can say let I2 be equals to integral of x raised power 2 cos x dx. Therefore, we can find an expression for I2. That is, wherever we see n here, we substitute 2. So that will give us x raised power n, that is x raised power 2 sine x plus n 2x raised power 2 minus 1 cos x minus n into n minus 1, that is 2 into 2 minus 1, in minus 2, that is 2 minus 2. So therefore, I2 is equals to x squared sine x plus 2x cos x. We can write 2x raised power 1 minus 2 into 1 I naught. So we can write I2 to give us x squared sine x plus 2x cos x minus 2 I naught. Now, if you look at this expression of I2, we'll see that what is missing that we are yet to find is I naught. So let us evaluate I naught. So we call that in from here is equals to x raised to power n sine x plus nx raised to power n minus 1 cos x minus n into n minus 1 multiplied by in minus 2. So when n is equals to 0, we'll evaluate that I naught is equals to x raised to power 0 sine x plus 0 x raised to power 0 minus 1 cos x minus 0 into 0 minus 1 I0 minus 2. Now this nullifies to give 0, likewise this. Therefore, our I naught is x raised to power 0 sine x. And anything raised to power 0 is 1. Therefore, I naught is equals to 1 multiplied by sine x, which is equals to what? Sine x. Now we have evaluated I naught. Then we now have to put I naught and substitute it into I2. Now let's quickly take a look at another way to evaluate I naught. We recall that in is equals to integral of x raised to power n cos x dx. Therefore, I naught will be integral of x raised to power 0 cos x dx. Now this is integral of 1 cos x dx, because x raised to power 0 is 1. And this will be integral of cos x dx, which will give us what? Sine x. So either we go through this means or we go through this means. Now, since we have been able to evaluate I naught to give us sine x, then we now substitute it back into I2. Let's recall what I2 is. I2 is equals to x squared sine x plus 2x cos x minus 2 I naught. And we know that I naught is equal to what? Sine x. Therefore, I2 is equal to x squared sine x plus 2x cos x minus 2. We make our substitution of I naught to be sine x, sine x. Then we add our constant of integration plus c. So we understand from the question that our I2 is the same thing as x integral of x squared cos x dx. Since I2 is equal to integral of x squared cos x dx, it is the same as x squared sine x plus 2x cos x minus 2 sine x plus c. In our next video, we'll be taking another example of using reduction formula for integrals of the form x raised to power n cos x dx.